All right. Hi, everyone.
Hey guys.
So this is Sam and Kyle from Arweave. Yeah, and today we're going to tell you a small amount about the system, how you can use it, and maybe how you do so in the NuCypher context. Thanks for taking time out to speak with us. So very briefly, Arweave is a new kind of decentralized web where all of the data is permanent. It's built on a new kind of blockchain we call a blockweave. Well, this is great because it's a technical audience, so we can get into it. Essentially how it works is instead of having just the hash of the previous block in the production of the next block, you also have the entire contents of a randomly chosen old block from the network. And what this means is if you don't have access to that old block, you can't take part in the mining of the next block. As a consequence, as a miner, you have an incentive to store those old blocks. And because hashing is substantially more expensive than storage, you're incentivized to optimize for storage ahead of hashing. So you essentially try and store as many of the old blocks as you can in order to have the chance to take part in the hashing on the new blocks. And as a consequence, it makes this sort of permanent information storage network. So on top of this layer, we built this thing that we call the permaweb, which is essentially just like the normal web, except everything you see on it is permanent. So once you have a permaweb address for a piece of information, you know that you can always come back to that address as long as there's an Arweave node online to serve you the data. So in the NuCypher context, we see this working in two different ways fundamentally. The first being when you have a piece of ciphertext that you want to store and you want to be able to delegate access to other people, you can use the Arweave as the permanent storage system to make that work. And then you can also store the UI front end that the user will use to interact with the system on the Arweave. And what's really nice about this is, essentially it follows the same pattern as the DApp, right? So the DApp lives forever, which is pretty cool. But if you don't have a UI that also lives forever, you can't really interact with the DApp. So if you store your UI on S3, it might get lost. Whereas with Arweave, once you have this address for it, you know it's always going to work. So if it's immutably there next to your DApp, you know that the DApp is going to work indefinitely.
Yeah, and a key detail, it's HTTP based, so you can integrate with browsers easily. Like when you upload a UI, for example, for an application to the Arweave, you can serve that over HTTP directly from the network. So there's no intermediaries required. There's no real integration. You just get URL and that's it. You're good to go.
Yeah, exactly. So the way that the nodes in the network talk to each other is actually over HTTP. So when you point the browser at a piece of information in the network, it's essentially no different than another node talking to, as the nodes talk to each other in the normal distribution of the network. So I guess we'll get into some demos to show you what you can kind of do with the system. And then we'll just deploy an app and see how it goes, I guess. And if you have any questions at any time, just, I guess, write in the chat and we'll keep an eye on it. So I share my screen here. All right, cool. So here is an Arweave application. So you can see here that there's the arweave.net domain name at the top, and then this hash, which is actually just a transaction ID. So what's happening here is because we can't see if you can tell this. Yeah, we have this Arweave web extension installed. When you go to this web page, it'll be served to you directly from the Arweave in a decentralized manner. But if you didn't have this web extension installed, then what would happen instead is you would hit the typical DNS server that would say, oh, okay, you want to go to this IP address, and that IP address relates to a load balancer that we run. And then that would send you on to an Arweave node.
But all of that is just for ease of access as well.
Exactly.
So if you just literally set up an Arweave node from scratch, you can just point your browser to your node's IP address / and then any transaction ID that it knows about, and you will get served HTML in your browser with no further setup.
Yeah, exactly.
Really easy to set up.
So the reason we do this is so that you can have access to this decentralized web without modification to your setup at all. And pretty critically here, this also means you can do it from your mobile. Not sure how useful that would be in a NuCypher context, because it doesn't seem like most of the use cases are things you would do from a mobile, but it's something you can do with the system. So really basically here, the network has served us this minified piece of JavaScript, HTML, CSS, which renders this page.
So I guess one of the only real differences between how you would deploy a normal front end is just that because the actual HTML lives directly in the transaction, typically you might have, your index HTML, you might have a CSS file, a JavaScript file, they can all live separately, that's fine. In our context, it makes sense to bundle it and inline all of your assets because you want to try and keep your data as atomic as possible. It would be possible in this example to like upload your CSS, get your transaction ID, embed that in your HTML, and then reference it that way. But it's a bit more clunky, I guess. So we've got some tooling out. We have like an Arweave deploy CLI tool for helping you upload some of your data, and that will take care of your inlining for you. So you can just give it like an index HTML file that references a style sheet and a JavaScript file, and it will just inline all of it for you, so you don't really have to think about it too much.
Yeah, so what you see here is the minified output, but when you're developing it, and we'll show you what this looks like in a second, then it just looks like we're building a typical web application. So we can see here what this does is it's a proof of existence machine. So if I say, give it this shouter.html file, it queries the network and says, okay, when was a transaction that included this hash last or first seen in the network? So it's saying this file definitely existed before this date. And if we click this, it'll take us to the Arweave block explorer, and you can see, the encoded data here, so the hash, and you can see the block that it was mined into, how many confirmations it's had, that kind of thing. But from the point of view of the application, you can also, so let's see if there's something here that I haven't actually already uploaded. I was testing this. No.
Uploaded, no.
Hopefully that's, there we go. So we press the button, we drop a file on it. In the background, it's hashed that file.
Oh, maybe let's take a look at the network tab as well. This is all HTTP based. So the application is just sending off other requests back to itself.
Yes.
And querying other data. So I guess you can refresh the page.
Yep. So we can see here, it's downloaded the document from the network, and now it has a way of talking to the nodes on the network. So then it can also say, so when we, this again, it was, that one, it's done what we call an RQL request. So it's gone off and said, all right, these can, let's get rid of this bar so I can actually see it. Zoom UI in the way. So it says here the expression I'm looking for, chronolog hash, and it's got this, literal hash. And then the network is saying, oh, okay. It's actually not very helpful, is it? It's not recorded the data. But the network has come back and said, okay, there are no transactions that have this tag associated with it.
Yeah, so what RQL allows you to do though, so I guess like if you think about like a typical web application, you have a backend, right? You've got somewhere where some logic will happen. In a decentralized front end, it doesn't really make sense to speak to a traditional sort of like speak to a specific server somewhere, because like that server is probably going to disappear one day, the domain might disappear, you have issues like this. So RQL allows you to query other data that's on chain. So, and that's all HTTP based again, so you can just use a simple web request to go and fetch other assets and other bits of information. Like Sam just demonstrated in this example, you can say, find transactions that match this key and value, and then you can do some functionality around sorting and things as well.
Yeah, so what it's saying here is find me everything with the chronolog hash, but you can also add, and we'll show some more in a second, ones that filter by app name, for example.
So you can just attach arbitrary tags to your transaction. So for example, when we uploaded this chronolog web page, we added a content type of text HTML so it gets rendered correctly, but you can add any sort of arbitrary keys and values, and they would obviously depend on like your application context. So here we're just attaching a hash to a piece of data. Maybe you want to attach, I don't know, a summary to your blog post. Like you can attach any arbitrary data to a title. Yeah, maybe that makes sense.
But so in the context of a NuCypher app, what you might do is you say, okay, well, give me all of the pieces of data that this user has encrypted, and then from here I can delegate access through the normal mechanism.
Yeah, so RQL allows you to, example, filter by wallet. So you could say, get all of the transactions and get all the pieces of data associated with this wallet address, and RQL will let you do that.
One thing we probably should mention is that you can't do this by data, though. This is only on tags associated with the transactions. So you can't say, hey, find everything that's got the word music or something inside the data segment of the transactions, just the tags associated. Okay, fine. So let's see if we can minimize that a bit. Okay, now we need to drop a key file. So these key files, we got a test one here. It says transaction dispatch.
Cool, nice, setting it up. That's pretty cool.
Yeah. And so we can see here it's got a post to stroke TX on, it's using this Arweave gateway, but it could use any Arweave node.
And it'll obviously, like, the nodes will then forward it around the network, so it is completely, like, it doesn't really matter where you send it to, Arweave.net, a specific node, yeah, it doesn't really matter.
Yeah, exactly, they'll pick off.
Oh, I forgot to mute.
Sounds that way. Yeah, okay, so you can see here that the transaction itself is just a bunch of JSON. So we have a bunch of different libraries that allow you to generate these transactions and send them to the network. One for JavaScript, one for Erlang, one for Java, one for what else?
There's a Scala one knocking around. There's a few other integrations as well. I'll link to one documentation. There's a PHP library as well if you're feeling adventurous.
Well, yeah. Old school, maybe. I'm not sure if there's one for Python though.
No, we don't have a Python one yet, which would be useful though. Yeah. But like, I guess even if it depends on your application as well. So like, if you're just interested in querying data, like that's all HTTP based. So you can literally just use a normal HTTP library. The only real complexity is around just generating the transaction and signing it itself. But again, it depends on your tooling and your language you're using. So difficult that is.
Yeah. So if you're doing it in Python, it'll be pretty trivial, I think.
Yeah.
If you go to docs.arweave.org, there's all of the documentation you need to use the system. So you can see here, it sort of gives you examples as well. And then also example code for example, transaction signing. So how exactly do I get this to work? Yeah, so that's fairly simple to set up. So back to this example. So it sent this transaction here, it's generated the data JSON using the JavaScript library in this case. It sent the transaction around the network, plausibly in a NuCypher example. This might be your ciphertext you're sending to the network to store. And then later you can say, hey, give me all the ciphertext and the RQL mechanism.
And I think it's worth just drawing attention again to the tags here. So it's just an array of arbitrary keys and values. Add as many as you want. And they are limited in scope, so you couldn't, for example, upload like a 1 gigabyte tag, but it's useful for like indexing and associating data.
Yeah, exactly.
And everything's base 64 encoded as well, so it's I guess you can't
base 64 URL.
URL safe encoding, yes.
Yeah, that trips people up sometimes.
Yeah.
But all of this stuff is in the docs. So we can see here we send this transaction to the network. And if we go to the Q block, let's see, has it been mined into a block yet? So look, so we go here. Yeah, it's got this hash. So now we go back to Chronolog and we say, okay, fine. Let's pick the file again. Now this time you see it does this RQL request, and it comes back and it says, oh yeah, there's this transaction that has the hash that you're talking about. So then we say, okay, fine, give me the status of that transaction. And this is literally just headers, yeah, stroke TX, stroke the TX ID, and then status. And this gives you the number of confirmations, which is pretty useful, and the block that the transaction was mined into. So it can use this to then say, okay, give me the data associated with this block. And it says, right, let's see, somewhere in here is a timestamp, and then it renders the timestamp. It's very basic. But it's a useful kind of thing you can build on top of the system, and it kind of shows how all the querying and those sorts of mechanics work.
Yeah, I mean, like with the libraries, this took like an hour or two to get set up, which is pretty cool. So.
Yeah, exactly. So again, in the case of NuCypher, what you could do is you could have a DApp UI like this running inside the browser, and then it could upload the data from the user's machine onto the Arweave where it's stored, and then you can delegate access in a sort of normal mechanism. So another example would be Weavemail. So this is a kind of decentralized email system that we built on top of the Arweave. This was, again, I think this is 186 lines of JavaScript or something.
Yeah, again, just with the library, it's just, yeah, you just add your application code at that point. You don't have to deal with like the actual network interactions, which is cool.
Yeah, so you just load in a key and it says, okay. I mean, one thing that's probably worth pointing out here is at the moment, the way that the trust mechanism works is that you essentially, you make a new wallet for every application, and then you only send as many tokens as you trust that application with. And that way you limit risk, essentially.
Yeah, because I guess you always have this difficulty with like, if you are deploying browser-based stuff, then you do have to be mindful of, the risks around how browsers work. Yeah, exactly. Yeah.
Yeah, they're always slightly broken, it seems. So here, this is kind of like the inbox page.
So this might be a cool example as well to just look at the network tab again, because I guess we'll see here it'll filter by some more RQL.
Yeah, I think the RQL is slightly more complex for this one. So we're going to have to reload. So, yeah, please excuse the terrible styling of all this stuff. We're not really, yeah.
So we've got our RQL query at the top. You scroll down.
Oh, yeah,
there we go. Cool. If you go to preview, should be nice and rendered as well. Cool.
Okay. Yeah, so here we can see that we're running multiple expressions, and this is just a kind of JavaScript payload that gets created that says, okay, I want to do an AND. So get me all of the transactions, essentially the union, where the to is to this address, and the application name is permamail. So all of the transactions that are sent to this address where somebody has said, this is an application of type permamail.
Yeah, and I guess the two again is just a tag, which is kind of neat because all applications are kind of sharing the same database in a way. So, for example, if someone was like, "Oh, well, I don't like how this front end works now," or "I need to like a feature" or something like that, someone else can just build an UI that does the same RQL query, and you will get the same data. You can render it differently or do something else with it. But
yeah, exactly.
It's pretty neat what you can do.
The data is unsiloed by default.
Yeah. So like all these websites are sharing the same backend and can kind of
yeah. But again, in this context of like a NuCypher application you might be building, if someone later thinks, okay, well, the backend application they built here is really cool, but the UI, I don't know, maybe we designed the UI. It doesn't look so great. So yeah, you can just like build a new version that uses the same data on the backend, and all of the users' old data is sort of available in the system by default. It's very simple. So you can see here it said, hey, give me all of the transactions associated with this, and then the response you said it was going to be nicer in here. Yeah, okay, cool. It's just returned this JSON list of transaction IDs, and so we can click one of these and hope. Someone's saying something very pleasant in my inbox there. So we can say, reply, say, it's a demo. And then you can also send tokens along with it. So what's kind of interesting about the data storage in the system is, they're all just transactions. So transactions have an optional to field and an optional data field and an optional amount of tokens to send. And all of those can be mixed together in any combination. So you can also send, like, I don't know, in the context of permamail, something like maybe a work order and also the payment for that work order atomically as one in a permanent context where that can never be lost. So you can say, no, actually, I did send you the signed contract on this date with the funds required to pay for the contract. Why didn't you complete it? Or, whatever it happens to be. So we press send, same thing, mail dispatched.
And again, that's just posted a JSON transaction to arweave.net/tx. That's all it's doing. Which is cool.
And from this point of view, like data is data. It doesn't matter if it's a piece of ciphertext or it's a mail. It's all the same. And then you can just filter them using RQL. And so like it's probably best to show this in a different way. In here we can see. So I don't know, maybe inbox is an interesting one to show. Okay, so here we're just building up this query that says, as we showed before, so you take the address and you use the Arweave.js library to turn the wallet that you have into an address, and then you say, okay, fine. Where the address is equal to this and the app is that, and then you await the response. So this is, one of the not so nice things about JavaScript is, I think, all of this weird await and asynchronous.
Oh, this is it's JavaScript. So.
So you end up putting in this weird async function here. But we're actually open sourcing all of this. So there should be some demo applications available in the next few days that you can like look through the source code of and kind of get a feel for yourself of how you might use it in your system.
Yeah, the actual libraries in TypeScript, so if anyone uses TypeScript, you can ignore a lot of the messages of JavaScript, which is quite nice, especially when it comes to crypto and typing. I think it's pretty useful.
Yeah, but the nice thing I think about our system is someone that learned JavaScript way early on when I was learning programming, and then moved from that to like more back-end stuff, Erlang and C and some assembly. yeah, I don't really understand the JavaScript frameworks, but the nice thing about the system is it doesn't require me to know. It's not like one of these weird things where the tooling takes 100 years to get used to, or it is for me.
Yeah.
But if you do use this kind of interesting JavaScript tooling they have nowadays, you can just do that as well. So it's quite flexible in that regard. Yeah, so here we're just saying, okay, get the document, just set the address at the top, and then for each of the responses, so each of the hashes that we get back from that RQL request, just make a new row in the table, and then add the pieces of mail. It's very, very simple. And all in all, across everything, there's just like 168 lines of JavaScript. And actually, pretty much all of the crypto is abstracted for you.
Yeah. Like all of that is just UI code as well. It's like, you could have 10 lines if you want a simple UI. But again, this is all use case specific. So.
Exactly. So I guess this is kind of like how you program the system, what you do with it. I mean, probably worth showing. You can get the JavaScript docs here as well, which I would say like JavaScript is the main way that people build applications on top.
I think when you look at like these decentralized applications, as you said earlier, I think JavaScript is probably going to be quite important just because we're hosting front ends.
Yeah.
So,
but possibly if you were just writing some kind of backend NuCypher application, you could just connect to it for the storage of the ciphertext.
Yeah. So I guess depending on your use case. Again, you might use it as a presentation thing. Here's your UI code, or just there is no UI. It's just machines talking to machines, and they just skip the whole HTML JavaScript altogether and just use HTTP. Yeah. And in this is at the moment, this is simply just like npm install Arweave, and you're pretty much good to go. You can literally just link this into your existing HTML, and you've got the Arweave library set up and ready to go. So you just edit it, give it a host, so you can point this to any Arweave node, just give it the IP address, or you can just use Arweave. Yeah, just literally one, or you can just use Arweave.net for ease. It's up to you. And then this is a functional example. Like this will work, and it'll go into. So if you replace this with Arweave.net, this will load the page, connect to Arweave.net, it'll pull the current block height and print it in here. So just to give you an example of how simple it is to actually write workable code.
Why don't we just do it? Yeah. So okay. So I've already got Arweave deploy installed locally, so I'm not going to need to install it. But to do that, you just do this npm install -- save Arweave. So there's it's a new file. Could possibly go wrong. Good. So let's change this and let's write this as.
And if we just change 127.0.0.1 to
so if it's actually served from an Arweave node, you can just leave this as stroke. Right?
You'll be able to. This is getting implementation, so just check out the docs, the specifics of the best practices. But because you can serve your UI over the same network, you can have your JavaScript here. Just say, for example, host will be window location, and then if you serve it under a different custom domain or something like that, or you'll serve it and you access it directly on your node IP, it'll just proxy calls to the Arweave network back to whoever's serving it. Yeah. So you can just speak to the same node.
So if the user used a gateway, or maybe they use their own node, then you can use that to just say, hey, just talk to whoever served you the page in the first place. Yeah. But here we'll use Arweave.net.
And in this example, if we just change the port to 80, and then just add protocol of HTTPS.
Yeah. How do I do that?
And that's pretty much it. Which is neat.
Okay, cool. So something worth noting is that you can call out to other decentralized resources, but you don't have to. So here we're using a centralized serving mechanism to get this web bundle.
So as an example, this will work, but don't deploy your code like this. Right. You've got external dependencies. If you use the Arweave deploy CLI tool, that will look at your external references. It will see this, for example. It will go and grab all of the JavaScript source. It will minify, inline it, and then replace your script tag with a basic coded inline asset, which is But the developer experience, you don't have to get into that.
Yeah. So as long as you're using Arweave deploys package flag, then you can basically just write it as if it was a normal centralized service, and then it will inline the assets and make the package atomic.
Basically. Yeah. So I guess we should post a link to the docs when we're done, I think. Because it's all explained in there, like in a bit more depth.
Yeah, it's literally just docs.arweave.org.
Yeah.
Okay, so if we say Arweave, in the chat, can we go into more detail on how Wildfire works? Yeah, we certainly can. So Wildfire is, or let's get this transaction mining first. I'll just come back to that. So Arweave deploy, and what do I call it? Test.html. Okay, cool. So Arweave deploy test.html. Let's say -- package. So this is going to run a very simple packaging tool that will take all of the content that we have externally linked and then dump it all in the file atomically. So that, well, the resource is permanent.
Yeah, this is only really useful though for UIs. Like you can just upload like any data really. Like maybe you just want to upload a bunch of like a JSON data set or something, and then you don't have to worry about packaging because it's not really in scope.
And so is it -- key file? Key dash file?
Key dash file, that's good.
Yeah. And it's test _ key file JSON. No, it's not actually a valid key file. Okay, but if it was a valid key file, it just says this is going to cost you this many tokens. Oh, another thing to note is you can go to our website and you can get a bunch of free tokens that you can use to deploy on the system already. So we give you 5 tokens, but that's more than enough for what you need in the hackathon.
Yeah, so like, you get 5 R and like to upload a normal web page. I guess if we just check on Viewplot, we can see some of the prices for like how much did like the funnel cost, for example. So that was the
that's a good idea.
Off the top of my head, I'm not really sure, but it will be like fractions of a fraction of an hour. It's outrageously cheap. 0.35.
0.35. That's actually quite a lot for.
But you can see, like you can deploy tens of applications with those 5 R, like no problem.
Oh, 0.035.
So,
okay, not very much. Right, yeah. And if you do happen to run out of tokens, just come talk to us on Discord and we can send you some more. It's such small quantities. We're happy to get people started with the system.
Wildfire question?
Yes, okay, that was interesting. Yeah, so Wildfire is basically a modified version of what BitTorrent does with optimistic tit for tat. That is, if Kyle sends me data, I'm going to send data to Kyle. But if Kyle doesn't send any data to me, I'm not going to send data to Kyle. And then there's this optimistic element to it, which is like, but I will try it the first time once every while. And this is what stops the system tending towards no one sending data to everyone and tends towards everyone sending data to everyone. So if everyone does this sort of occasional optimistic send, then the whole system just sort of optimizes towards lots of data being sent around. So the difference in our system is that we also apply this to block and transaction distribution. So in order to be a good miner in the network, you need to have access to the latest blocks and the latest data transactions as fast as possible. Otherwise, you're going to fall behind, and you'll essentially spend time mining on the wrong fork or mining on a block that no one's going to accept. So we just distribute these transactions and blocks with the same mechanism that we do for prioritizing data distribution. That's pretty much how it works. What's kind of cool about the network, though, this part of the network, is that it's totally off-chain, which means that it's very, very low burden on the infrastructure of the system, and also it sort of maps to the underlying substrate of the web, or rather the internet infrastructure. So if Kyle is in Sydney and I'm here in Berlin, and then someone else from our team is in London, say, then the likelihood or the strength of the connection between here and London is going to be much, much stronger. So I would prefer that as a data distribution mechanism than sending it to Sydney. As a consequence to this, you have this sort of wildfire effect where the data just sort of spreads around the network and around the globe, in an efficient manner.
Yeah, it's kind of interesting, when you like literally map it, you can see, for example, like we have a bunch of nodes sat there in like a data center in London, for example. They all prefer each other because they have such low latency connections, which is interesting. And you can see how that maps around, different data centers around the world.
And like they will talk to the nodes in New York much more strongly than they will the nodes in San Francisco.
Which is cool. But in practice, it's like, I think we look at like an average like transaction propagation time, something like 7 seconds across that node.
Oh, it's much less than that.
Yeah, and that's like the worst case. So it's,
And block propagation, I was looking at the other day, it's like 1.5 seconds or something.
Which is pretty cool.
Yeah, it's very fast. It's neat. Yeah, so that's Wildfire. That's how you send transaction to the network and provide video. Yeah, I think they're going to put the video on YouTube afterwards. Block shadowing in comparison to sharding. So block shadowing isn't really about sharding in the same way. We actually have sharding in the system, but it's kind of natural sharding. So thinking back to that proof of access mechanism that I outlined at the beginning, the essential principle is that if you have access to the piece of data required, the recall block, then you can take part in the mining on that block. But if you don't have access to that data, then you can't. As a consequence to this, the network fits into natural hashing shards. But this is sort of different to block shadowing. Block shadowing is basically decoupling the transaction distribution layer from the network from the block distribution layer. So what that means in practice is when I receive a piece of data, I send that data to Kyle, and then I wait until I'm reasonably confident, I'd say 99% confidence value, that everyone else in the network has got that piece of data. And then I start mining it into a block. And that means when I found this block, I don't have to distribute that transaction data again, which is really important because it means that when the block is propagated, the block is like 1.5 kilobytes or something. Rather than if it were like a Bitcoin style block where it actually contains all the transactions, it takes a lot longer to propagate in the system. This is obviously really important for us because our transactions contain large amounts of data. They're not just financial transactions. Yeah, so that's block shadowing and how it fits into the system. It's essentially a kind of like data distribution smoothing system. So you can like keep a consistent flow of data exchange rather than having like spikes when blocks are propagated. It sort of keeps the consensus time in the network down. What else is there to show? I think that's sort of broadly everything.
Yeah, I think that's most of the key points.
Yeah, I guess we just show if you go to arweave.org and then you go to getting started, or either of these buttons, in fact. Then you can get some free tokens. You just click on this, and so on. You go through, and you can do it with. We had it for a while with a GitHub and a Google account.
Yeah, it turns out people really like GitHub plugins.
Well, the problem was,
but GitHub does not provide enough security for us to reasonably hand out 5 art. Unfortunately, Google does that.
It's a bit of a shame. We would like to offer different services to log in with. All we're using the login for is just making sure that people don't spam it.
Yeah, basically. But like you said, if anyone's got any particularly interesting use cases, like feel free to like email the team, reach out, and we're happy to like work and get tokens to people.
Yeah, I mean, it's fine. If you don't want to give us your Google login,
you can email.
Then just send an email or just send on Discord. Someone will send you some tokens. I don't think anyone uses the content policy at the moment to employ blacklists, but we expect them to very shortly, actually. So what we're doing here is trying to make it so that that system is nicer to get on board with. At the moment, you can do it, but you have to know this really weird file format. I'm not sure many people use that.
Yeah, so we're working on making it more accessible to miners so they genuinely understand like what it is they're blacklisting and how the system works.
Yeah, and also making it so that you can call out to other blacklists that are essentially controlled. Because what we find is when we talk to charities that provide these kind of hashes of malicious content, essentially, they don't want people giving out the hash lists, but they are okay with you building a service that says, fine, if you send me a hash, then I'll tell you if it is on the blacklist or not. It's kind of centralized. We don't particularly like it, but it's
and it's all optional, though, right?
Yes.
So I guess like in future we'll probably see sort of like kind of like how Adblock works, where you have like community maintained lists.
Yes,
that's
the idea is that then they basically become something akin to political parties. So one group of people say, okay, we think these and these and these things should be censored, essentially. Other people think not so much, and then they vote with their hashing and storage power. And then, even after they vote and something's, say, rejected from the network, and fine, no one stores it, But if it's accepted into the network, even then, the people that don't want to have anything to do with it just don't have to store it. They simply don't get the reward for storing it either. So where we'd like to go with this eventually is to make it so that you can call out to other web services that do stuff like looking at what's inside an image and that kind of thing, and then telling you in a way that you can make it work with your system.
Yeah, and I guess like it throws up a bunch of interesting problems because like I guess like depending on the jurisdiction of the miner, for example, they might have issues with storing, for example, some type of content, whereas the jurisdictions it's not an issue. So I guess it's important that we genuinely give miners usable tools for these sort of things, and that's where we're going with this.
So it's been there since launch, but we're making it much.
So I guess like to answer the question directly, like it's not been employed as of yet.
Not as far as we're aware.
Well, that we're aware. Yeah, that's true.
People do all sorts of things. That's something that like is worth pointing out, but I don't think we actually said. The Arweave mainnet has been live since June last year. So everything that you've seen here is all running on the mainnet. This is this is real working stuff, and this is exploring.
We have a mining community. There are miners. This has all been live for approaching a year. Pretty cool.
So I think we're basically come to the end of what we have. Security side and others. There are some things that are different about the system in terms of security, but most of it is still pretty close to Bitcoin, actually, which was like the archetype that we were working with when we were building the system. So really, in that way, like most of the interesting questions about like 51% attacks, that kind of thing, is all pretty much in line with Bitcoin. I guess the difference would be that you're not just talking about hashing power, you're talking about storage power as well. Okay, I guess if there are no further questions, then we'll leave it here.
Awesome. Sam and Kyle, this was amazing. Very, very in-depth and educational. Where could participants learn more about Arweave and get involved more into your documentation and learn more about what you guys are doing?
Everything's linked to from Arweave.org. We've also got a Discord server, which like the team are active on as well, so you can talk directly with us if you've got any questions there. Arweave.org. All the information should be available from there.
Arweave.org.
Definitely join our Discord. So if you've got any questions at all, you've got to get in touch with us in real time. So.
And there's plenty of people around there that are always helping out with like answering questions.
The community can help out with questions as well. Some people are like working on projects currently, and they'll drop in and talk about like how they're finding it and give useful feedback. And there's plenty of people that help out.
I guess this hackathon runs for a month, right? So in that time, there'll be a couple of updates to the deployment script. Everything's under heavy development right now. So like, there's a nice thing that gives you better debugging output. So I guess just watch for our Medium, which is medium.com/@Arweave. And then you'll see like, when we release an update to that.
Amazing. Thank you guys again so much. And I hope you guys have a wonderful day.
Thanks for taking the time. Really appreciate it. All right.
Have a good one.
Ciao.